Hello ATS 113 students, Dr. Shragi here, helping you sort through the reading assignment for Lecture 3. We're going to be talking in this section about the vertical structure of the atmosphere and different ways in which you can break the atmosphere up into different layers and talk about the features of those layers. And then we're going to move on and talk about some of the radiation laws and the ways in which we can move heat around in the atmosphere. A lot of what the atmosphere is doing is moving heat around. Later when we're talking about winds, when we're talking about the general circulation of the planet, we're going to need to know why the atmosphere needs to move heat around in the way it does. So you're going to start on page 14 and you're going to learn about ways to sort the atmosphere out based with the vertical structure of the atmospheres with respect to density. And on this page, don't worry too much about this box about different temperature scales. Hopefully you know about the differences between Fahrenheit and Celsius. And then we're going to talk about ways to sort the atmosphere out into layers based on temperature, or more accurately, based on how the temperature changes with respect to height. In some layers of the atmosphere, the temperature decreases with height, and in some layers of the atmosphere, the temperature increases with height. And we're going to sort out the atmosphere principally in this manner. The lowest layer being the troposphere, which is topped by the tropopause. All of the weather that we learned about in this class happens in the troposphere. I like this picture of a thunderstorm here that kind of shows you that there's a sort of top to the thunderstorm. That's at the top of the troposphere, or the tropopause. Above the troposphere is the stratosphere. Stratosphere is where like ozone layer is and things like that. The top of the stratosphere is the stratopause. Oh, here's an important vocabulary word for you. Inversion. Make sure you understand what a temperature inversion is. Alright, and then the next two layers up when we sort the atmosphere out by temperature profile are the mesosphere and the thermosphere. Okay, but after we're done with these breaking up with layers, the rest of that chapter is about things like the ionosphere and so on. This is upper atmospheric things affecting satellites and radio transmission. I'm not as interested in that, so don't worry about that part of the chapter. Rather, at that time, move on to chapter 2. I believe this is page 30. We're going to start talking about moving heat and energy around in the atmosphere. Now there's a couple paragraphs here that you're going to be responsible for. We won't have time to talk about them in class. They're circled in red here, starting with energy. I think this is page 31, perhaps 30. And moving on into the next page, these paragraphs about kinds of energy. This is going to be about talking about the differences between kinetic energy and potential energy. And there are some examples of both of them in the textbook, and I hope that I'll be able to field some questions from you guys after you've read this with examples of your own of both kinetic and potential energy. Okay, then we move on and we start talking about different ways of moving heat around in the atmosphere. Some of them are going to be very familiar to you, like conduction. This is when two objects that are of different temperatures are touching each other. Some of them are going to be less familiar to you, like convection and advection. Now, possibly the most complicated of these processes is going to be radiation. In fact, the rest of the lecture is dedicated to radiation. Radiation is a way of transferring heat from a hotter object to a colder object without them actually touching, but rather through space or through a distance. For example, the sun heats the earth by radiation. I want to stress, radiation is not the same thing as radioactivity. Okay, radioactivity is broken molecules from atomic reactions and so on. Radiation is a perfectly natural phenomenon. It can be harmful, but it's things like light, microwave radiation. We'll talk about lots of examples both in the text and in class. There are going to be two different properties of radiation that we use to measure how strong the radiation is and what kind of radiation it is. And these properties are going to be the amplitude of the radiation and the wavelength. Make sure you have these properties, you have a firm grasp of these properties by the time we get through this lecture. Okay, so you continue reading through this section, and we're going to learn two important radiation laws that describe the amount and the type of radiation that every object will emit. Remember, everything emits radiation. And emitting radiation is an important property because it is giving off heat when it is emitting radiation. Right now you are emitting long-wave radiation, a type of radiation that we'll see in just a few minutes. The amount and the type you are giving off depends on these two rules. One is called Stefan-Boltzmann's law. Make sure you know Stefan-Boltzmann's law. And one is going to be called Wiens Law on the next page. By the way, I like this graph at the top of this page here. Make sure you you're able to see what the difference is between these two plots. And here's a hint. Check out the x-axes of these plots. Okay. This page, the top part is a text box that you don't need to worry about. That's a little bit more detailed stuff than we cover in this course. And here's Wiens Law. Wiens Law has to do with how hot the object is going to determine the type of radiation that the object gives off. And based on these two laws, we're going to be able to sort out the radiation in the atmosphere as being either shortwave radiation, which is radiation that comes from the sun, and long-wave radiation, which is radiation that comes from the Earth. Both kinds of radiation are passing through the atmosphere, but they have very different properties and very different influences on what the atmosphere is doing. Okay, then the next two pages are about the sun. It's a nice little text box explaining how the sun actually works. It's actually quite interesting, but it's beyond the scope of the class, so for now don't worry about that. And so here's the next page. Again, it's all about the sun, it's about sunspots. It's interesting stuff. If you need a study break, look through it. It's pretty cool. But the last page I want you to actually pay attention to here is page 42, which is about the solar constant. The solar constant is an expression we use in meteorology to describe how much radiation from the sun reaches each square, I think in the book we use square meter of the Earth's surface. And this is a roughly constant number, and we're going to talk in this section about what factors influence the solar constant and how big the solar constant is and what the units of it are and things like that. Alright, I hope this information has helped. It'll certainly speed you through the readings a little bit. And this has been Dr. John Schrage, copyright 2006.